Okay, in the last class I said up to the drift, and next is the diffusion. Okay, drift and diffusion are very important. Without these two questions there will be no question paper, so please be careful and read very sincerely. Okay, so diffusion. Okay, in the case of the diffusion, we know that diffusion means diffuse. Okay, so due to the non-uniform carrier concentration of the charge carriers moving from a region of higher concentration to the region of lower concentration. Okay, so let us consider one of the glass with the water, and whenever we pour some of the sand in it, what will happen? The water will be excessed. Okay, that means we are pouring the water from the higher region to the lower region. Okay, or we are taking the sand and we are pouring in that, then what will happen? We are we are placing the sand from the higher region to the lower region. Okay, whenever we are doing like that, some of the water will be excessively, they will come out of the water. That means there will be the excess electron concentration will be presented. So excess electron concentration is represented by delta n. Okay, delta n be the excess electron concentration. Okay, now we have to find out the formula for the diffusion, but we don't know any formulas, but we are having the formula from the Fick's law. According to the Fick's law, the rate of diffusion is directly proportional to minus dou of delta n by dou x. Okay, so this directly proportionality constant is represented as dn, where dn is the diffusion of electrons. Now the current density Jn diffusion is equals to minus E into minus dn dou of delta n by dou x. So this is the formula for Jn diffusion, and this is for the Jp diffusion. Okay, now we are representing, so this is up to the diffusion. Now we are writing the total current density in terms of drift and diffusion. Jn drift plus Jn diffusion, Jp is equals to Jp drift plus Jp diffusion. That means we are combining the both the equations. Okay, we have to write up to this for the drift and diffusion. And the next concept is the direct and indirect band gap semiconductors. This is also important for the 2 marks question. Okay, so what is meant by direct band gap and what is meant by the indirect band gap? That means in the case of the direct band gap, the minimum of the conduction band lies directly above the top of the valency band. That means there will be in the straight manner. Okay, the minimum of the conduction band should be lies directly above the maximum of the valency band. That means electrons in the conduction band will recombine with the holes in the valency band and emits a light of photon of energy h nu. Emits a light of photon of energy h nu. But in the case of the direct band gap, the lifetime of the charge carriers will be less. So the best example is the gallium arsenide. But whereas in the case of the indirect band gap, the semiconductors, all the semiconductor materials, whatever we are considering, they will not have the minimum of the conduction band directly above the top of the valency band. That means the band gap will be shifted by a k vector relative to the valency band. The indirect band gap, the lifetime is very more, so that the lifetime is more, they are used to amplify the signals in case of diodes and transistors. The figure we are representing is like this. Okay, so here the minimum of the conduction band is not lying directly above the top of the valency band, they are shifted by the k vector. Okay, so the best examples for the indirect band gap is silicon and germanium. Silicon and germanium. What are the silicon and germanium? They are the pure form of semiconductors. Intrinsic semiconductors are known as the indirect band gap semiconductors. Okay, and next is the density of charge carriers. In case of the intrinsic semiconductor, we are represented n is equals to nc e to the power of minus of EC minus EF, and we have represented the formula. How the formulas are be represented? That means the formulas that came from the density of the charge carriers. Okay, so for that we have to calculate the density of electrons. So N is equals to, so for that we are considering that Dn is a number of electrons, and in the energy levels E and E plus D, and Dn is equals to, okay, this is totally the derivation part. Whatever the equations I have written, you must read it, you must practice it. Okay, d of e, f of e, and now we have to integrate the equation so that we get, okay, here we have to represent one of the most important formula here according to the Gauss law. Okay, so sorry, according to the gamma theory, that is using the gamma function. Here we are functioning that integral of x to the power of half e to the power of minus x by kt into dx is equals to, this is a formula. Okay, this is from the gamma function or gamma rule, we can say that, so that we can get the formula. Okay, in the same case we are density of the holes, we get P is equals to NV into e to the power of minus EF minus EV by KT. Okay, so this is full of the derivation. Please practice it and you can do it. If you are having any doubts, please represent in the comment section. Okay, next, in the next class I will say one of the important 10 marks question which is known as the Hall effect. Okay, one of the most important question. I can make sure that this question will be presented for the 10 marks question in your question paper. Okay, so